Okay, so I'm going to try to be more to the point this time so I don't have to make a third video for the next example. Okay, so a study using 2 random samples of 35 people found that each average amount of time that those age groups were 26 and 35 years spent per week on leisure activities was 39.6 hours. And those in the age group of 46 to 55 years spent 35.4 hours. Assume the population standard deviation for those in the first age group found by previous studies was 6.3 hours, and the population standard deviation of those in the second group found by previous studies was 5.8 hours. At an alpha of 0.05, can it be concluded that there is a significant difference of average of times in each age group spends on leisure activities? Okay, like I said in the previous video, there is a lot of information here. So what I would go through is pause the video now, underline, and label. The big things we're looking for here are mean, standard deviation, sample size. Label them as X bar 1 for your means, sigma for your standard deviations, and n for your sample size. Go ahead and pause the video and do that now. Okay, that being said, my null hypothesis, go ahead and do that here. My null hypothesis in this case would be that mu1 equals mu2. My alternative hypothesis will be that mu1 is zero difference, so not equal to. Once again, I don't know how to do that symbol in Google Slides, so I'll just write it. That's my null and alternative hypothesis. Okay. I'm going to go ahead and clear that out, so make sure you have that written down, please. And then moving on from there, I have a lot of this information here. So maybe I can do this. That's kind of hard to see. All right, well, we'll do the best we can with what we got. Okay, so let's do a confidence interval real quick first. So we'll push statistics, go to tests, we go to 2 sample Z test. Now the reason why I'm using a Z interval, we're doing interval, 2 sample Z interval, is because we know our population standard deviation for both, and we know that our sample size is over 35 for each population. So I can use a Z interval. All right, so we're given data. So my population standard deviation is 6.3 for group 1, which is the 26 to 35. My sample size for that group is 35 people. My mean on those average of those is 39.6 hours, and there's that. So now a second group had a population standard deviation of 5.8. The mean hours they spent was 35.4. And then a sample size for them was also 35. And then we're doing a 95% confidence interval because alpha and confidence interval are complements. So if alpha is 0.05, confidence level is 0.95. Okay, and there it is. It's that simple. So the way you would say this one is, I'll make this bigger and type on here. We are 95% confident that the true difference in population, let's say in difference on time spent on leisure activities is between, then I'll pull my calculator, and it said 1.4 hours and 7.04 hours. Okay. Sorry for the spelling. That's very quickly. I'm trying to do the point so I can don't make another third video. Okay. So that's the interpretation of the confidence interval. Okay. So now to do the test. The test, once again, is very straightforward. You just go to your statistics, go to tests. We are doing a 2-sample z-test. Oops. 2-sample z-test, which is number 3. And then you're just filling in the information. And because we did a confidence interval already, it should all be there for us, which is, like I said earlier, very convenient. We just calculate, and then all we're going to be doing here is comparing our p-value to our alpha. And just going to type that interpretation real quick. Since the p-value of 0.004 is less than an alpha of 0.05, we reject the null hypothesis. Please make sure you actually put down the p-value and alpha. Otherwise, it's not technically correct. There is sufficient statistical evidence to suggest that there is a difference between hours spent on leisure activities between the different age groups. And that would be that. Very simple, straightforward, and we'll go from there. Okay. So that's how you do that problem right there. I'm going to go ahead and delete this, so if you want to pause and write it down, please go ahead and take the time to do that. Okay. Now let's go to our next example. Now, one thing I have to say here is that you're going to need to convert everything into one term of units. Before I read this problem, you're going to notice that there's pounds and ounces. You're going to have to convert either to pounds or convert completely to ounces. It's up to you which one you want to do. Just know that there's 16 ounces in a pound, and you should be able to go from there. Okay, so just going through this problem quickly. Research here wishes to see the average weights of newborn male are different from the averages of newborn female infants. She selects a random sample of 10 males. There's under 30. It's going to be a 2-sample t-test no matter what I do. With 7 pounds 11 ounces, and standard deviation is 8 ounces. She selects a random sample of 8 female infants and finds the mean weight is 7 pounds 4 ounces, and the standard deviation of the sample is 5 ounces. Can it be concluded that an alpha 0.05 that the mean weight of males is different from that of the females? Okay, so this is how I'm going to go to pounds just because that's just what I want to do. So I'm going to go ahead and go to, we're going to do a confidence interval first. 2-sample t interval, and then we're going to go ahead and just put all our information. Don't worry about whether it's pooled or not. Just leave that no. Do not mess with that. It's going to ask you that. Don't worry about it. That's for future courses to help you with. Mean said 7 pounds 11 ounces. So what I'm going to do is I'm going to say 7 plus 11 divided by 16, because like I said, there's 16 ounces in a pound. So that's going to be our mean. Our standard deviation was 8 ounces, which is half a pound. Our sample size 2 is 7 pounds 4 ounces. So I'm going to say 7 plus 4 over 16. And then, oops, that's sample size. I'm sorry. We said there was 10 males. 7.25. Standard deviation was 5 ounces, I believe. Yes, 5 ounces. 5 divided by 16. Sample size there was 8. Our confidence interval is 0.95, and then we just simply calculate, and then there's our confidence interval. So we are 95% confident that the the average difference between male and female birth rates is 0.02 pounds and 0.84 pounds. That's that. If you need to pause the video to write that down, please do so. I'm going to go ahead and jump right into the test because I'm starting to run short on time. 2 sample t-test. Oops, that's number 4 here. Once again, all the information should be there from before. And we're doing a not equal to situation, and we're going to calculate. And our p-value is 0.04. So what you would say is our null. Since the p-value of 0.04 is less than an alpha of 0.05, we will reject the null hypothesis. There is sufficient statistical evidence to suggest that there is a difference between male and female birth rates. Now, that is that. But you also please just realize that that number is really close. It won't work for a 99% level or a 0.01 level of confidence. All right. So onto your homework, just so I can end the video. Please do not do these assignments on separate Google Docs. Please, if you can, put them all into one Google Doc and turn that in. That would be wonderful. Thank you very much. If you have questions, I'll be on my office hours.